Okay, in this video, we're going to go over the notes for 6.2. So I'm going to create notes for you on the screen. So this is all about right triangles. Remember, you can only do these relationships with SOHCAHTOA in right triangles. Okay, so SOHCAHTOA is sine of some angle equals opposite over hypotenuse. And then the cosine of some angle equals adjacent over hypotenuse, and the tan of some angle equals opposite over adjacent. Okay, so you have to remember what that means. It's abbreviated as SOHCAHTOA to help you remember that. The first time through, we just talk about words, and from this angle's perspective, the opposite is straight across, and the adjacent is touching it. So sine of beta is opposite over adjacent. Okay, cosine of beta is adjacent over hypotenuse. Tan of beta is opposite. Let me change my color. Opposite over hypotenuse. Okay, so you may have known those from your geometry class, but these are the reciprocal functions. So take the sine, and to get cosecant, so that's cosecant, you are going to flip that over. Oh, and I did that incorrectly, so let me fix that. This is over hypotenuse. I think I said that and wrote something different. So that means that, excuse my handwriting here, that means that this is hypotenuse over adjacent. Cosine's adjacent over hypotenuse, so it's hypotenuse over adjacent. And tan was opposite, oh my gosh, losing my mind here, opposite over adjacent. Here we go. Opposite over adjacent. So therefore, it is adjacent over opposite. Pardon me. Okay, so I use the colors to identify the reciprocals. So here is another expression telling you that they are reciprocal functions. Okay, moving on, the bottom triangle, we then did numbers. We're only dealing with alpha. So from alpha's perspective, right across the triangle is the opposite. Right next to the triangle is the adjacent, and across from the right angle is always the hypotenuse. Okay, so find the 6 trig ratios of angle alpha. Sine of alpha is opposite, which is 20 over hypotenuse. Cosine of alpha is adjacent, which is 15 over hypotenuse. And the tan of alpha is opposite, which is 20 over adjacent, which is 15. So remember, writing SOHCAHTOA, not a bad idea, so that is right in front of you. Okay, so I think I'm good there. Okay, so now we have the reciprocal functions. So reciprocal of sine is cosecant. Flip that little puppy over. And the reciprocal of cosine is secant. Flip that little guy over. And lastly, the reciprocal of tan is cotan. Flip that over. Okay, so we're done. On this page, you want to memorize this. Okay, memorize. Okay, now for here, this is just calculator input. So you're going to type in your calculator sine of 30 degrees, and you're going to write the numbers. Now, a couple of things. I am stressing to you that when I say round to 3 decimal places, that's what I mean. So put your mode, in your mode, you're going to do 2 things. Make sure you're in degrees, not in radians, and move the float to 3. Those are the 2 things you're going to do. Okay, you should get these answers, and I did these in class. These are all in degrees. Okay, then you're going to move into radians. The only thing you're going to change, go into your mode and change the degrees to radians. So this is all radians. Keep your float on at 3 and find these values. If you get a negative answer, include the negative in your answer. Once again, we are reinforcing the fact that these are reciprocal functions. Okay, let's keep going with this. Now, this is a hugely important page because you have to understand some of the conventions. Here are the conventions that we're going to use. Uppercase letters represent triangle vertices, and they are used as the angle identifiers. Lowercase letters represent sides, and side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. Okay, so you want to definitely know that, and I'll talk about that more as we go. Okay, on with this conventions and the basics of Pythagorean theorem, which is what? Pythagorean theorem is c squared, the biggest side, equals the sum of the squared legs. Sometimes you're going to need to do that because they're not going to give you all the sides. Okay, this is what's given. So right here is given. The second I give you this, you're going to start drawing. Okay, now, everything has to be a right triangle because we are doing, say it together, right angle trig. If it's not a right triangle, you do not use these ratios. Okay, I can't stress that enough. This is just for right angle trig. There's my right angle. They tell me that C is 90 degrees. That has to be C. They then tell me side values for A and B. So I'm just going to call this C. They call the triangle ABC. So I'll be A, B, C. Across from C is little c. Across from A is little a. Across from B is little b. What have they given us? A is 5. Write in a 5. B is 8. Okay, what have they not given us? Let's highlight that. I have not received information on C, on this angle, or on this angle. Okay, so what are we going to do? We're going to figure this out. Okay, so I am seeing that I have two sides of the triangle. It's a right triangle. I'm going to do Pythagorean theorem. The C side is always the biggest side. It's not just the missing side, okay? It's just the biggest. So I'm going to say C squared equals, A in this case I picked to be 5. B in this case I picked to be 8. So that's 25 plus 64, which is what? 89. That is C squared. That means that C equals radical 89. That's an exact answer. Do not put it as a decimal. Okay, so I have that side. Now I can do everything. Okay, from A's perspective, here is A. From A's perspective, the opposite is going to be the A side, right? So the sign is going to be, and we're going to write SOHCAHTOA. From A's perspective, opposite over hypotenuse is going to be 5 over radical 89. Now look, we're telling you that you have to rationalize the denominator. That's what it means if you have a radical down there, you can't keep it. Don't do anything with that yet. Run through the problem once and then go back and rationalize. Okay, so cosine from angle A's perspective, cosine is going to be 8 over radical 89. Tan it's going to be 5 over 8. Okay, now let's do reciprocals. Here they are. Sine goes with what? You have to memorize this. Sine goes with cosecant. S goes with C. Flip that bad boy over. So I'm going with cosecant, right? So sine and cosecant. So that over that, go back to tan, that's going to be 8 over 5. And secant is going to be the flip of cosine. So that's radical 89 over what, 8. Okay, now comes the time to rationalize. What do I need to rationalize? Only this guy and this guy. Okay, so I'm going to rationalize them now, and I'm going to say multiply that by whatever the radical was over itself. That answer, 5 root 89 over 89. Again, multiplying by radical 89 over radical 89, 8 radical 89 over 89. Done. Those are my answers. Okay, now let's do sine. Let's do all these trig functions with respect to angle B. Okay, moving into that now. We'll do that in blue. Here's angle B. Its opposite is the 8. Okay, so we're going to do sine and cosine and tan. We're going to get 8 over radical 89. Leave it be for right now. 5 over radical 89. Tan is 8 over 5. Now, cotan is the flip of that, 5 over 8. Cosecant is the flip of sine, radical 89 over 8. And secant is the flip of cosine, radical 89 over 5. I have 2 to rationalize. What do I have to rationalize? This one and this one. I now focus on the relationship between angle B and angle A, and I see when I rationalized cosine of A, I got 8 radical 89 over 89. I'm just going to use it again. When I rationalized sine of A, I got 5 radical 89 over 89. So look how there's a relationship between these. Sorry about that. It was the end of the day. Okay, so we have all of our answers. You can see the commonality that the tan of A is the same as the cotan of B, and so on. Okay, the cosecant of A is the same as the secant of B. You can see that there's this relationship. You should be seeing it. All right, let's keep going. Now this says, given that sine of alpha is 4/7, find the values of the 5 remaining trig functions. Okay, what do they assume that you understand? They assume that you understand you have a right triangle. And when they're going to speak about the sine of an angle, they will never, ever, ever be talking about that 90 degree. They're going to be talking about the 2 acute angles that are with the 90 degree. So you can put that angle either on the top or the bottom. I'm going to put mine at the bottom. That angle, the sine of that angle, is opposite over hypotenuse. Something is missing. This is missing. You can't do anything until you get that. So what we're going to do is I'm going to label my triangle CD. Well, I'll do it with the regular letters so we can line up the Pythagorean theorem just for instruction's sake. Okay, so it's going to be A, B, C. Okay, step 1, find the missing side by using C squared equals A squared plus B squared. The C side is always across from the right angle, so 7 squared equals, these are interchangeable, but we picked this order for the 4 and the question mark, which I should probably make an x, so we'll make this into an x, okay, plus x squared, or we can make it plus b squared, whatever you want to do, it doesn't matter. Okay, so what do I know? This is 49, that equals 16 plus, and maybe to be consistent, we'll call that b squared, okay? I think I like that a little bit better, so we'll make that b. That means that over here, we'll make this b, so that you're being reinforced with what your sides are called. Okay, so now I'm going to say 49 minus 16 is going to equal b squared. And 49 minus 16 is what, 33. That equals b squared, but I want b, so that's radical 33. Okay, so I need this. This is key before I finish this problem. Okay, I've got to get this. Now, let's see if we can do the following. I want all 6 functions, say. So I'm going to write them down. So I need the sine of theta. They told me it was 4/7. It's still 4/7. Okay, then I want the cosine of theta. That's going to be radical 33 over 7. Then the tan, opposite over adjacent, that's going to be 4 over radical 33. Just make sure I have this right. Okay, yep. And what else do I need? That's tan, right? So now I've gotten all of this stuff going. Okay, so this all right? Yep, this is all good. Okay, so next, why don't we just go ahead and get the reciprocal functions right away? So I'm going to change to red. Sine goes with what? Cosecant. And that's going to be 7 over 4. Cosine goes with secant. And that's going to be 7 over radical 33. And tan goes with cotan, which is going to be 4. Flip it. Radical 33 over 4. Okay, I have got 2 that I need to rationalize. I have this one, tan, and secant. They both have problems because they have a denominator that is a radical. I can't have that. So let's go ahead and we'll rationalize that. Hopefully this will fit. So I'm going to say radical 33 over radical 33, and that's going to be 4 radical 33 over 33. And the secant is going to really be, once rationalized, 7 radical 33 over 33. Okay, so now everything is rationalized, and those are your answers there. Okay, we're going to keep going. We're doing solving a right triangle because these are great problems. So when they say you want to solve a triangle means find all sides and all angles. Okay, so first thing, in geometry and in lots of math classes, you want to make everything visual. They give you some words and you can draw a picture. You are foolish if you do not do so. Okay, so this says triangle DEF. Okay, so D is the 90, so I know where D is. And that's all I really know. Oh, no, I do know E. Okay, so I'm going to say DEF. F is 41. Excuse me, E is 41. Little f is across from big F, and that's 20. Okay, so what don't I know? All right, I don't know a couple of things. I don't know this value right here. I don't know this value. And I don't know this value. I do know that that box means 90. Why don't we first try to find missing angle? So find angle F. Now, angle E and angle F are complementary. Therefore, to find angle F, just say 90 minus 41. Okay, if it was 90 minus 40, that would be 50. It's 1 less. So therefore, I get 49 for my answer. So 49 degrees is this answer. So let's change the color. And this is going to be 49 degrees. Okay, and I'll take away the pink now. So let me just do that and see if I can go there. Oh, that's a problemo. Okay, we'll take care of this. Let me just not be so careless about doing that. Okay, I've got that. And now I have to put a 49 here. So that's 49. That was one thing I had to find. So I've solved for the angle. That was the easiest. Now I have all my angles. I'm going to use the angle they gave me to solve for what else is missing. So I'm going to write SOHCAHTOA. So I'm going to write that right here. And when I write that, I'm going to say, okay, let's see. I have the angle, so opposite and hypotenuse I don't have. I'm missing both of them. I have adjacent, and that's all I have. So which one uses adjacent? Oh, good question. So let's see. Which of these has adjacent in it? Well, there's adjacent and there's adjacent. So I can only use cosine and tan to solve. Okay, let's use tan and see what we can get. So the tan of 41 degrees equals opposite, which is little side e, over adjacent, which is 20. So do your cross products. 20 times the tan of 41, and what do you get? You should be getting, and that equals e, and you should be getting that e equals 17.4. So this is now 17.4. Okay, what else can I use? I'm not going to use what I just solved for because clearly that's an approximate answer given the decimal. So I'm going to find the hypotenuse by doing cosine because that's also highlighted. So the cosine of 41 degrees equals 20 over some d. Do cross products. D times the cosine of 41, that equals 20. Okay, isolate d, cosine 41, cosine 41, and you're going to get d equals, see? Okay, hang on one sec. We're going to put this in our calculator. So if I have, 20 divided by the cosine of 41, what am I getting? 26.5 is what I'm getting. 26.5. Okay, so I am all set with everything I needed. I'm going to put this here so I can see that I've solved for the missing pieces. And remember, the other missing piece that I found was right here for the angle. Okay, so that's solving a triangle. You've got all the pieces now. Let's keep going. Here's another one. But this is going to be super hard the first time you see this. But you can do it. I have faith in you. You're going to have your calculator in radians mode. So right now, switch over to radians mode. I'm going to go into my mode. I'm going to go to radians. I'm going to say second quit, and I'm all ready to go. Okay, let's draw your triangle. Again, if you're not drawing it, I don't know how you are going to be solving these things. So let's draw my triangle. It has to be a right triangle, otherwise I can't do these things. They say that C is pi over 2. So you have to remember that pi over 2, so if I convert that, isn't that 90 degrees? That one is key. Don't change your angles out of radians. That is pi over 2, but I wanted to make sure that I knew which one was 90 because position mattered. Okay, so let's do the rest of this. So I'm going to label this triangle ABC. They tell me this is taken care of. Angle A, right here, this angle, oh, look at this angle. 8 pi over 45. Do not panic, we can handle this. Little a is 24. What's missing? This is missing, this is missing, and that is missing. So those three pieces are missing. Find the angle first. As I said before, A and B are complementary. So to find the angle, what will you do? You're going to do a subtraction. And you're going to say pi over 2, which is 90 degrees, minus 8 pi over 45 is going to equal angle B. Okay. Now, you have to make both denominators 90 because 45 is odd, so that's not going to work. So take your pi over 2, and we're going to multiply it by 45 over 45. Take your 8 pi over 45, and multiply that over 2 by 2 over 2. Now, let's see if you can figure out why I picked those numbers. This makes 45 pi over 90, and this makes 16 pi over 90. You see why I did my multipliers the way I did? Because I now have 90 in the denominator. And this is going to be, what, 29 pi over 90 equals angle B. Okay, Angle B, right here we just found 29 pi over 90. Don't worry about doing anything else to it. It is fine the way it is. Okay, then you have to find missing sides. So I would use the angle they gave you. So the angle they gave you is angle A. So I'm going to write SOHCAHTOA again. So here comes SOHCAHTOA. If the angle they gave you is A, 24 is opposite that. So I'm going to highlight where I have the opposite here and opposite there. So I can use sine and tan with the given information to get the missing information. Okay, so let's try to work on our sides rather. So I'm going to say the sine of 8 pi over 45 equals 24 over little c. That means little c times sine of 8 pi over 45 is going to equal 24. Just doing cross products, remember this times that. Okay, so now isolate your c. C equals 24 over the sine of 8 pi over 45. So when you put this in your graphing calculator, you should get an answer that is 45.3. That is this side. It should be the biggest side. So far it's bigger than 24, so that seems reasonable. Okay, I just used sine. I'm going to use tan now. And I'm going to say the tan of the angle they gave me, which is 8 pi over 45, equals opposite, which is 24, over little side b. B times the tan of 8 pi over 45 equals 24. Isolate your b, divide both sides by tan 8 pi over 45. Okay, so this is the tan 8 pi over 45. Those will cancel. And when I do all this, I'm going to get b is going to be equal to, let me just look at my notes. So I have 38.4. Okay, so then this is 38.4. And have I solved for the triangle? Is anything missing? No, so I'm all set. Okay, so this was in radians, so I had to have my calculator in radians, and I had to be comfortable working with fractions in radians. You may want to go over this again. Okay, let's continue. Now we have some applications. These are very fun because they're real life examples of when you would use this. Okay, geometry type things and trig type things have lots of practical applications. Okay, you want to read this little thing about the line of sight so you can see from this guy's vantage point, if you look straight out, looking down towards the hypotenuse of this triangle is the angle of depression. Okay, if you're on the boat and you're looking up towards the top of the cliff, that's the angle of elevation. Now, guess what? Those two angles are equal. Why? Because this is parallel to your line of sight. That makes the line of sight a transversal, and it makes the two green angles I've identified here and here alternate interior, and they are equal. Okay, so you're going to bear that in mind. It comes up in a later problem. Angle of elevation is demonstrated here. It's from the horizontal to the top of whatever you're looking at. That's your angle of elevation. Make sure you understand those. Okay, this is about both things being equal. Okay, so we're going to read these word problems, and we're going to not die. We're going to survive. A wire is anchored by a stake in the ground. It's going to be a right triangle. Just draw it. Okay, this is where the right angle is, right? Okay, a wire is anchored by a stake in the ground. The stake is located 550 feet from the bottom of a building. Okay, this is the building from the words I'm reading. This is the wire. This distance from the wire where it's staked to the building is 550 feet. Make sure you can understand my drawing based on the wording. The wire's angle of elevation. So here's the sight line right down here. Look up to the top of the building. That's where the angle of elevation is, right there. How tall is the building? So they want to know, we're going to say h for height of the building. So from this angle's point of view, if I do SOHCAHTOA, what have I been given? From that angle's point of view, I've only been given adjacent. What do I need? I need opposite. Adjacent and opposite are covered in tan. I'm going to use tan to solve this. So the tan of 27 equals h over 550. 550 cross multiplying times the tan of 27 will give me the height of the building. Go back, make sure your mode is in degrees. The last thing I did, I was in radians. So I'm going to say mode is in degrees. Okay, plug that in. So let me make sure I'm in degrees, so I can quit. And 550 times the tan of 27 gives me 280.239. And did they say what they wanted it to? I'm going to say let's do it to the 10th. This is smaller than 5, so you don't round up. So I'm going to say the height equals 280.2, and the units are feet. Okay, let's keep it going. Another wire problem. A construction company needs to run a support wire from a stake in the ground to a top of a cell phone tower that's 300 feet tall. Okay, I have an idea of what they're saying. Draw your triangle. Again, it has to be a right triangle. Okay, I'm going to read again now that I have my drawing. A construction company wants to run a support wire from a stake in the ground, here's the ground, to the top of the cell phone tower. This must be the tower. And the tower, that is 300 feet tall. So this is going to be 300 feet. If the angle of elevation, that's from the ground looking up, is 38, how long is the wire? Here is the wire. How far is the stake from the ground to the bottom of the tower? So this is the stake, right? And so I need this measurement here, and I need my wire measurement as well. Okay, I'm going to write SOHCAHTOA. Okay, from the angle 38's perspective, I have opposite, okay? So I have opposite, opposite. And what do I need? I need both, right? So I need the hypotenuse for the wire, and I need the adjacent for the stake distance from the tower. So let's use sine first. Sine of 38 equals opposite over hypotenuse. So the wire is going to equal sine 38 times 300. And we are in degrees. Okay, so sine 38 times 300. The wire is going to be 184.7 feet long. So this is 184.7 feet. Done. So that was one of the things they wanted, and we just got it. Okay, next point. Now let's use the excuse me, unused tan. Tan of 38 degrees equals opposite over, and we'll just call this x, over adjacent. So x times tan 38 equals 300. X equals 300 divided by the tan of 38. Okay, so if I do 300 divided by the tan of 38, I'm going to get X equals 383.98. So I'm going to probably round that to 384.0, really, right? So this is 384.0. And what is going on here? Oh, wait, hold on a second. I did not get that. I'm sorry, I told you a wrong number. For the wire length, it's not that. What is it? I think I just put that in the calculator wrong. Oh, right. I shouldn't do that. What am I doing? Hopefully you were yelling at me when I was doing this. I should be doing 300 over the sine of 38, and then that will give me a bigger number. It'll be 487.3. Yeah, I knew something was not making sense. And so how did I catch that? So I'll tell you since I write it down. The way I caught that I must have done something wrong was because the length of the bottom. Good afternoon. Okay, sorry again. Okay, so what I noticed when I had these two answers was that my length down here was bigger than my wire, and it can't be because this is the bigger side. So that's how I found that. Okay, so think about what I did. Don't make the same mistake. But if you do make the same mistake, always make sure your answers seem reasonable. It is not reasonable, nor is it possible, to have the hypotenuse smaller than one of the legs. So you will catch a mistake very quickly right there. Okay, we have 3 more problems to do. So let's keep going. Okay, an airplane is flying at an altitude of 10,000 feet, approximately 1.89 miles. If the pilot calculates his required angle of descent, that's a depression angle, to the airport to be 2 degrees, how far away is the airport? So what I noticed is they gave me 2 numbers over here, 1 in feet and 1 in miles. I'm going to use the miles because most likely I want to talk about how far away it is from the airport in miles and not feet. Okay? So first thing, you're going to draw that lovely triangle, and it's going to look like a right triangle. And if your plane is up above you, you would make that the vertical height. That's the altitude straight up from where you will be standing. Then they say, okay, this little pilot's up here in the plane. His angle of depression is here. That is 2 degrees. Remember I told you the angle of depression is equal to the angle of elevation down here because of alternate interior angles being equal? Well, that's true here as well. Here is the airport. Here is the plane. I want to find this distance. So I'm going to use the 2 degree angle, but look where it is. It is down here. It is absolutely not there, okay? Don't put it up there. Okay, from that angle's perspective, I'm going to write SOHCAHTOA because that's a great way to get myself started. I write SOHCAHTOA, and from this angle's perspective, I have the opposite, and I need the adjacent. Bingo! I'm going to use tan. Okay, so tan of 2 degrees equals opposite 1.89 over x, which is the distance to the airport. Cross products, tan of 2 degrees, 1.89. Isolate your x. Isolate your x. X equals 1.89 over the tan of 2 degrees. So I am in degrees. That is my mode right now. And I'm going to say 1.89, because that's the miles, divided by the tan of 2 is going to be 54. And it looks like it's about 54 miles exactly, right? So this is 54, you can say 0.1 if you want, miles. And that seems reasonable. Okay? Here comes another problem, problem 8. At a point 200 feet from a production building. Okay, building's probably going to be the vertical component, but let's see. The angle of elevation to the bottom of a smokestack is 35 degrees, and the angle of elevation to the top is 53. Find the height of the smokestack. Oh, that's kind of cool. Okay, so let's do a fictional type thing. Well, actually, what I'm going to do first off is I'm going to move this down, and I'll show you how we're going to handle this. Move this down a little bit. And I think I'd like to draw a second kind of piece of this triangle. Okay, so the angle of elevation to the bottom of the smokestack is 35. Let's make this right here 35 degrees. That means that here's your building. Let's say that this is your smokestack. So that's your angle of elevation to the bottom of the building. Now, it also goes on to say, and the angle of elevation to the top is 53. Okay, I'm standing in the same spot measuring these angles of elevation. Here is the top. I have to come kind of right down and go right there. Okay, so what do I know? I know this entire red angle is 53 degrees. And look at this distance right here. This is going to be the height of the smokestack. So let's think about this. Why don't we find the height of the building first? And do I have another number someplace? Yeah, it says 200 feet away. So that means that down here is 200 feet from here to here. Okay, so let's do SOHCAHTOA again, because we're going to figure out what we're going to use. Okay, let me turn on my highlighters. Okay, from the 35-degree angle perspective, I have the adjacent and I want the opposite. Adjacent and opposite, I'm going to use tan. Okay, so tan of 35 equals x over 200. This being x right here, and that's from here to here. Okay, so do that multiplication. 200 times the tan of 35, and I'm getting x equals 140. Okay, so this is 140. Okay, now let's find the distance from the ground to the top. We'll use the 53-degree angle. I'm going to say tan of 53 equals, we'll call this y, equals y over 200. So 200 times the tan of 53 is going to equal what? Y is going to equal 265.4. Does that seem reasonable? It does, because that should be more than the previous one. And then I want to find y minus x equals what? Subtract those. There you have it. That's the height of the smokestack. Okay, here comes the last problem. Skyscraper and a high-rise apartment building are separated by 900 feet on the ground. Okay, how do I do that? Well, I'm going to draw. Here's my skyscraper. Here comes the ground. Okay, and then I'm going to assume, for illustration purposes, that my high rise may be shorter. Okay, so we're going to call this skyscraper. So this will call it sky. This is ground. And this is going to be high, just so we can distinguish from them. They go on to say that they're separated by a distance of 900 feet. The angle of elevation from the skyscraper, so right here, to the top of the high rise, right here, boom, is going to be 18 degrees. Okay? So they eventually want to know how tall the high rise is. Let's do that first. Okay, so the high rise. So I'm going to say, let's just try to get our high rise. And we're going to say, okay, from that angle's perspective, I have the adjacent and I want the opposite. Opposite and adjacent is tan. So the tan of 18 degrees equals, we'll make this x, equals x over 900. Okay, so 900 times the tan of 18 gets me x equals 292.4. Okay, so that's helpful. 292.4 feet is how tall what? That's the high rise. So this is 292.4 feet. This 292.4 feet. Let's continue. How tall is the skyscraper? Well, I have to read the rest of the problem. The angle of depression from the top of the skyscraper to the top of the high rise is 34 degrees. Oh dear. Okay, so I'm going to go from, I'm going to draw, let's see what I'm going to do. I have to think about this. So the angle of depression up here. So it's going to, we're looking this way, right? And where is he looking down towards? He's looking down towards the top of the high rise. Okay, that's where he's looking. And that's going to make that triangle right there. So that's an angle of depression. And that angle of depression is 34 degrees. So if that's 34 degrees, I still know this is 900. Can't I figure out what this is? This is y. So I can say, okay, from angle 34's perspective, I have the adjacent and I need the opposite. That's still tan. So the tan of 34 is going to equal opposite, which is y over 900. And so that's telling me that the tan of 34 times 900 gets me y equals 607.1 feet. So how tall is that skyscraper? Well, everything they gave us, the angle of depression from the top of the skyscraper to the top. So that means that that's where I'm looking. That's building my triangle. I'm not going all the way down to the ground. If I know y is 607, then isn't my skyscraper, so 607.1, isn't that going to be 292.4 plus 607.1? So I'm going to add 292.4 to that, and I am getting 899.458, and they want it round to 1 decimal point. So because it's 0.45, I have to make that last one into a 5, go up 1, and that is in feet, and we are done. Okay, so this was a challenging one, but kind of fun to work with. We had to find the skyscraper indirectly. So to find that indirectly, what we had to do was draw this picture and then figure out what we were solving for was really the difference in heights between the high rise and the skyscraper. And to get the height of the skyscraper, you had to add them both together. Okay, so that ends this video. I hope this helped. I hope I gave you enough hints that you'll be able to do this section well.